Your browser tells a story about itself to every site you visit, and most of that story is told without your permission and without your knowledge. It is not your login, it is not a cookie, it is the shape of your device itself, assembled from dozens of tiny signals into something surprisingly unique. Signals and sites use that shape to tell a returning person from a stranger and to tell a real visitor from an automated one. Today, I want to explain how browser fingerprinting actually works, from the outside, the way a site sees it, and what it means for anyone doing honest data collection. I run proxy infrastructure and production scrapers, so I spent a lot of time on the defending side of this, understanding how detection systems work and how they are built. I want to be clear up front about the frame. This is an explainer of how the mechanism operates, not a guide to defeating it. I am not going to teach you to fake a device or slip past a check, because that is not the durable way to collect data, and honestly, it is not a game worth playing. Understanding the wall is useful, pretending it is not there is not, where the fingerprint even is. Start with the core idea. A browser fingerprint is a profile a site builds by asking your browser a series of harmless-looking questions and combining the answers. What is your screen size? What fonts do you have? How does your graphics chip draw a shape? What audio hardware do you report? No single answer identifies you, but stack 40 of them together, and the combination is often unique enough to pick you out of millions and to recognize you again later even with no cookie at all. That is the power and the problem of it. The user agent is just a claim. The most familiar signal is the user agent, the string that names your browser and operating system. But it is only text your browser volunteers, so on its own it means little, because anything can type any string into it. What makes it useful to a site is not the claim itself, but whether the rest of the browser backs the claim up. A client that says it is one thing, while every other signal says something else, has produced a contradiction. And contradictions are exactly what detection systems are built to notice. What the screen and system reveal. Your browser freely reports a pile of system details. The screen resolution and color depth, the number of processor cores, the amount of memory, the operating system and its version. Each one is coarse on its own. Plenty of people share a common screen size. But combined with everything else, these details narrow the field fast, and they carry consistency requirements. A device claiming to be a phone but reporting a giant desktop screen and dozens of cores is telling two stories at once, and that mismatch is more revealing than any single value. The canvas signal. Here is one of the clever ones. A site can ask your browser to draw text and shapes onto a hidden canvas, then read back the exact pixels. The result looks identical to a human eye, but at the pixel level it varies slightly from device to device, because the drawing depends on your graphics hardware, drivers, and system fonts. That tiny variation is stable for your machine and different across machines, so it works like a signature. The site is not showing you anything. It is quietly measuring how your specific hardware renders a picture nobody ever sees. WebGL and the graphics chip. Closely related is WebGL, which lets a site render three-dimensional graphics and, in doing so, learn about your graphics processor. It can read the make and model of the chip and observe exactly how it draws a complex scene. Because graphics hardware varies so much across devices, this is a strong contributor to the overall fingerprint. And like the canvas signal, it is passive from your side. You see a normal page, while underneath it your GPU has quietly described itself in enough detail to help separate your device from the next one. The fonts you have installed. The set of fonts on your system is another surprisingly telling signal. The exact list depends on your operating system, the software you have installed, and the languages you use, so it varies more between people than you would guess. A site can probe which fonts are present and build a picture from the answer. On its own, it is just one more coarse signal, but it stacks with the others. And an automated environment that ships a bare, identical font list on every instance stands out precisely because real people's font sets are messy and individual. Audio, time zone, and language. The signals keep going. The way your device processes a silent audio sample varies with your hardware and software, giving another faint but stable marker. Your time zone and your language settings add more, and they carry consistency checks of their own. A visitor whose address places them in one part of the world while their time zone and language claim another has produced yet another small contradiction. None of these is decisive alone. The method is always the same. Gather many weak signals and let the combination do the identifying. The network layer speaks too. Fingerprinting is not only about the browser. The network layer talks before the page even loads. The way your client negotiates its encrypted connection, the specific options it offers and the order it lists them, forms a pattern that real browsers produce in well-known ways. A lot of automated tools produce a pattern here that no real browser would send, because the underlying library was never trying to imitate one. So a client can claim to be a current browser in its headers while its connection setup quietly says otherwise, which is one more consistency check a site can run for free. Entropy, or how the signals combine, the word for what makes this work is entropy, which just means how much a signal narrows the field. A signal that everyone shares carries little. A signal that varies a lot carries more. Detection combines many signals so that even though each is weak, the total is strong. This is why you cannot think about any one value in isolations. The system is not asking whether your screen size is suspicious. It is asking whether the whole bundle taken together looks like a real person's device or like something assembled to look like one. The tells of an automated environment. So what gives an automated setup away? Real devices vary in messy, natural ways across all of these signals, while a fleet of identical automated environments tends to produce the same fingerprint again and again, or one carrying small tells a normal machine would never have. A browser driven by automation can expose properties that a human's browser does not. The detection system is not hunting for one magic flag. It is looking at the whole shape and asking whether it resembles the natural variety of real people or the suspicious sameness of a cloned machine. The long tail of signals, and the list keeps growing at the edges. Some environments expose battery status, motion sensors on a phone, the exact way a page scrolls or a pointer moves, even the subtle timing of small operations. Each one is another faint signal added to the pile. You do not need to memorize the full catalog. The takeaway is that the surface is wide and always expanding, so the number of places a device can quietly describe itself is far larger than most people ever imagine. Consistency is the real test. Step back and the pattern is clear. Almost every check here is really a consistency check. Does the user agent agree with the rendered fingerprint? Does the time zone agree with the network location? Does the claimed device agree with the reported hardware? Detection is less about catching one forbidden value and more about catching two signals that disagree. A real device is naturally consistent because all its signals come from one real place. An assembled identity has to keep every one of those signals in agreement, and that is genuinely hard to do. This tracks real people too. It is worth naming the other side of this, because fingerprinting is not only aimed at bots. The same techniques identify and follow real human visitors across the web with no cookie and no consent, which is a genuine privacy concern. A person clearing their cookies can still be recognized by their fingerprint. So this technology sits in an uncomfortable place, useful for telling automation from people, and at the same time a quiet tool for tracking those very people. Understanding how it works is part of understanding the privacy trade-offs of the modern web, not just the scraping ones. Why it is an arms race. This whole area never sits still. Detection methods get sharper, browsers add protections that blur some signals, and the measurements shift as hardware and software change. A signal that is strong today can weaken tomorrow, and a new one can appear. That is why I am wary of anyone who claims a permanent answer to any of it. The ground moves constantly under both the sides doing the measuring and the tools being measured. It is less a solved problem than an ongoing back and forth with no final state. What this means for honest collection. So where does a compliant operator stand in all this? Not in the business of faking a device to slip through, because that is a race you do not win and it is the wrong side of the line anyway. The honest position is to understand how the wall works, and then to not need to beat it. Collect public data at a polite rate. Identify yourself honestly where a site expects it. Prefer an official API or data feed because that is the front door the site actually built, and it does not care about your fingerprint at all. Understanding detection makes you a better engineer. Trying to defeat it makes you someone else's incident. The honest limits, let me be straight about the boundaries. Nothing here makes anything undetectable. and I would not trust anyone who says otherwise. Detection keeps improving, and the point of understanding it is not to evade it, but to know why the compliant path is the durable one. The moment collection depends on faking an identity, or reaches for private data, or ignores what a site clearly asks, it has left the honest lane entirely, whatever the tooling looks like. The version of this work that lasts is the boring one. Public data, honest identification, a gentle pace, and the rules respected. I run this infrastructure in production, so I study detection from the defending side because it makes the collection I build more honest and more durable. Not because I am trying to slip past anything. If you want to go deeper, the full written explainers, the privacy angle, and the compliant patterns are at dataresearchtools.com. Third person and defensive throughout, with no undetectable promises and no bypass how-to. The goal is to understand the wall well enough that you never have to fight it. A browser fingerprint is dozens of weak signals: the user agent, the screen, the canvas, the graphics chip, the fonts, the audio, the time zone, and the network handshake, combined into something unique enough to identify a device. Detection mostly hunts for contradictions between those signals. Real devices are naturally consistent, and assembled ones struggle to be. The same technology quietly tracks real people, and it never stops evolving. The honest response is to understand it and to collect in a way that never depends on defeating it. Subscribe for a new scraping infrastructure breakdown, and I'll see you in the next one.